So we have medium problem given a list of numbers. Alice plays versus Bob. In a game, they can take any number from this array, and if the running sum of this game is divisible by 3, Alice loses immediately. So this is not symmetry game. Like we can't just solve it for Alice and Bob would automatically invert its moves. It's not this kind of game. Size of array 10 to the power of 5. So this is not DP problem, not DP, because if we try to solve it with dynamic programming, we have to keep track of the current sum of Alice choice and the pile of numbers that would be impossible to track in a reasonable amount of time. So instead of, we have to observe this property of divisible by 3. Any number we can do this modulo operation by 3, and we have 0, 1 or 2 as a result. So we can classify those numbers like 1 divisible by 3 is 1, 5 divisible by 3 is 2, 7 is 1, and so on. After that, we have 3 numbers, like 3 reminders, and depending on them, the game is basically solved, because let's observe the second property of this game. Imagine Alice take first value 1. What kind of values can take Bob? He can take zeros, just to flip the turn, or he couldn't take 2 because he would lose, and he have to take 1. And after that, we have running sum of 2, and we couldn't take 1. We have to take 2. And after that, we have running sum of 4, and again we can't take 2 because it would give us 6, and 6 is divisible, so we have to take 1. And this sequence is defined, and it is the only one we can take. Same for the 2. It is the same, like 2, next is 2, we have 4, 4, next is 1, and so on. This is predefined sequences that are given, and we have just to observe the properties of these sequences. So and what about zeros? Zeros are flippers, flip the game. So if we have let's look at the solution. I didn't solve it myself, so I just don't want to invent the logic. So if this was this is what accepted, but this is not what I like. I like it different. So this is Kotlin one. If we have even number of flippers, so basically if we have 0 count divisible by 2 equals 0, basically we have 2, 0, 2, 4, and so on flippers. That means Bob can't turn the game Basically, if Bob uses one of the flippers, Alice immediately uses another one, and this is how it got mitigated. That means we only depend on count of ones and count of twos, and if we don't have any of them, then Alice loses. But if we have any of them, Alice just wins. Alice wins. Basically, if we have 1, 1, 1, Alice uses, and that's it. This is the finish of the game, and it is not divisible by 3. Same for the 2. And Alice can just go with this sequence and always win. Next condition, if we have one flipper that Bob can use. That means at some point of time, basically after Alice did her choice, Bob knows that she choose this her golden sequence, I would call it, that always win. And he flips the game. Bob says, hold on, let's invert your choice. And if Alice tries to predict the Bob and say he would turn the game, but Bob can ignore this 0. So this is a mind game where Alice always would lose. But in one step, she still can win if we have bigger difference between ones and zeros. Basically, if we have too many ones or too many zeros, she can force Bob to pick the ending trailing twos that would make Bob result divisible by 3, or trailing ones that would make Bob divisible by 3. So this is the logic behind it. This problem is all about this observations of the properties of modulo 3 operation, then observation of how we can always make this sequence, and it is the only one we can make. I would call it the brainteaser. And yep, that's it for today.